Hello. Today I'm gonna present our work on a blockchain system, StreamNet. It is a DAG system with a streaming graph computing. Uh, DAG means direct acyclic graph. So our technology is based on the graph computing technology. So why do we want to do this? The reason is that since the introduction of the Bitcoin, there are lots of different kind of the blockchain system being introduced. Because the core reason of the introduction of this blockchain system is that there is an essential problem with the Bitcoin consensus algorithm, because it can only support a transaction speed of 4.6 transaction per second. There are multiple ways to solve this issue. For instance, the BCH has increased the number of the blocks, a number of the transactions that will be supported in the block to 4 megabytes per block. So its transaction speed has been increased from 4.6 to 116. Litecoin has similar solutions. And another popular blockchain system, Ethereum, can only support 15 transactions per second. Repo has a high transaction throughput, but the limitation of the repo is that it is not a public blockchain system. You need a permission to join the blockchain. So we can see that there is a price to hash rate ratio. It is usually very high. So we want to minimize the price of the transaction. For instance, for the most recent days, the transaction price for the Ethereum has been skyrocketing high because of the introduction of some of the DeFi projects, such as the Uniswap. The price has becoming very, very high, and for those who really wants to roll out their project into the Ethereum, it's almost impossible because of the limitation of their budgets. So we need a public blockchain that is fast and cheap to resolve these issues. So we will be able to make the blockchain, especially the public blockchain, be available to anyone who wants to participate or contribute to the blockchain ecosystem. So we have introduced the StreamNet, and this StreamNet has these three properties. It is low cost, and it has the specific algorithms to ensure the consistency. So it basically have the same effect of the Bitcoin or Ethereum, and it has a very fast block synchronization, because this is very important. Suppose you have a blockchain system and it's distributed among the world in different places across all of the continent. If the synchronization is slow, every people might see different kind of the pictures, so you cannot say that your system is consensus. So our idea is like this: suppose that we have different kind of the machines in different places. Everybody will grow their own blockchains. For instance, this machine one has the block attached to this two blocks, and this one machine gets another block, and this machine 3 has another block attached to these places. But because of the gossip algorithm, everybody will finally sync these 3 blocks, and they will use the our blockchain consensus algorithm to compute a total ordering, so that everybody will see the same ordering of the picture and use this ordering to reach their consensus. So this is the a picture of what a system that looks like in the local machine. Each local machine will have a transaction pool. This is received from the local RESTful API call, or received from the gossip algorithm from the other machines. And once they receive these transactions, they will use this block generator to generate the blocks. And the blocks will try to attach their block into the local DAG by referring the previous two transactions. One is the main transaction, one is the reference transaction. And so this is the general architecture of a local machine. So what is the algorithm to compute the consensus? The general idea is that because we have a DAG graph in the locally, we firstly want to compute a pivot chain. Using this pivot, this example is the pivot chain. This is like a G1356 is the pivot chain, and each pivot chain will be used to define an epoch. For instance, there are 5 epochs here in this figure, and using this epoch, each epoch pivot block in the epoch will include other blocks into their epoch, and use this epoch to flatten the graph into a chain. So use this chain to compute the total order, and use this total order to define the consensus. So you might ask, what is the consensus? The consensus is very useful because of the double spending problem. For instance, now we have this block, the ID is A, and it has this transaction out, which means the Alice has 5 coins. If the Alice wants to spend this 5 coins, for instance, it wants to transfer 1 coin to Bob and 1 coin to Jack. Because if we have used our total ordering algorithm to flatten the block into one chain, there will be an ordering. From logically speaking, it is very obviously that this is a double spending, because Alice wants to spend 1 coin at the same time and transfer this coin to Bob and Jack at the same time to trade for some of the things she wants. Maybe a service, maybe a good. So we don't want this thing to be happen. So what can we do? We flatten this DAG into a chain and give them an order. So in this order, we find that Alice transferred to Bob. This event is happening before the Alice transferring the coin to Jack. So we just reject the later transaction because of the ordering. We want to give a rule that that things happen beforehand is trustable, and the later on is the double spending. So this is the usage of our total ordering algorithm. So another issue is that we want our synchronization, or let's say it is a gossip algorithm, to be fast as fast as possible, because if it is not fast enough, the packet might be lost on the way, or it might takes extremely long time to let everyone see the same picture. So we want to have a gossip algorithm, better gossip algorithm. So for example, if we have this type of this structure, like a 3-click, everybody might want to receive the same information. But if the architecture becomes this complicated, one node might receive a lot of duplicated messages. For instance, the node number 1 might send some information to number 4, and this number 4 will send information to number 7. At this meantime, the number 1 will also send the message to number 7. And also probably number 6 will send the same information to number 7. So there will be a lot of the duplicated messages. And because the block size is large, it might take about 1 megabyte or even more. So this will make the whole network flooded. For some times, this is not tolerable. The hackers might initiate a DDoS attack based on this feature. So to prevent this happening, we designed an algorithm, the gossip algorithm, to emulate as minimum possible message as possible. So this is by the message signature. Instead of sending the whole block, we only send the signature, so that we want to make sure that every message to reach a node, the storage complexity will be the message size itself as an upper bound. So this is what we do. This is what we do, the gossip algorithm. The result is here. This is the single transaction, which means each block will only have one transaction. We can see that with the growth of the number of the transaction, we really have some TPS that is growing, but there are some of the noises over here. I think it is because of the implementation of the function limitation of our implementation. There are lots of the flakiness in our implementation. It's also true for the multiple transaction algorithms. So in summary, we have proposed the algorithm to implement the DAG system, and we do implement the system, but there is a lot of the flakiness in our implementation. I think it is one of the biggest problems of the current blockchain system. The implementation on this distributed system is very hard. It will be a lot of flakiness, and this type of the flakiness is really hard to reproduce. I mean, it's really engineering productivity problem. We don't know how to solve this problem at this moment yet. That's the reason why there are so many good ideas in the market, but very limited implementation. For instance, Ethereum 2.0 has been delayed for maybe even half a year now. I think the reason is because of the engineering issues. You want to propose a new idea and you want to upgrade it, and how do you make sure that it's secure? How do you make sure that it will not introduce some security problems? So that's the issue. This issue is even bigger than the transaction speed problem we are trying to solve now. I hope everybody in the technology can realize this problem and can contribute their resources, maybe their time, maybe their intelligence, maybe their money, to help solve this issue and to build a decentralized world. This world will be will have much more freedom, and will have much more power than a centralized world. So you can ensure your privacy. You can ensure that your idea will not be controlled by a centralized machine or a centralized mindset. Thanks.